everybody. Thanks for coming out on Good Friday. I think Ed and I realized 48 hours ago that today was Good Friday. But this is the third Friday breakfast SIG, so that's what it is. But it's a pretty good turnout. So what I'm going to talk about today, this is actually an updated version. It's updated because IoT is certainly a very fast-moving segment right now, so nothing really stays in one place for too long. I originally gave a version of this presentation at IoT Tech Expo in California last November. So this updated version of that, and I hope you find it interesting. A little bit about me. So I'm a serial tech entrepreneur. Or glutton for punishment. These things are equivalent in a lot of ways. I spent most of the last 25 years in the telecom business. I started a number of different companies, all focused around what is called an ESP, or enhanced service provider, doing voice recognition, IVR systems, fax services, and that type of thing. I've been a pretty active angel investor for about the last 10 years. I've also been a startup mentor to a number of companies, some of the local accelerators here like Tech Wildcatters and Health Wildcatters, also a couple of other companies, mostly local, some as far away as Austin, San Antonio, that type of thing, but don't typically get too much outside of that geography. And I'm a space geek. That's a whole other story, but I've been very interested in this manned spaceflight program. Pete knows exactly what I'm talking about. We'll have a nice conversation about that if anybody's interested. So the company that I founded in 2016, this is actually my 19th startup, and it's called ObjectSpectrum. And it was a direct result of doing angel investing and mentoring in 2015, 2016 timeframe, where I was working with a number of companies that were either directly involved in the IoT space or were working on something that was somehow IoT related. And through my experience working with them, plus my telecom experience and electrical engineering experience and that type of thing, it really seemed like there was a missing piece in the IoT ecosystem. And that's what I set out to fill with ObjectSpectrum. So in short, we provide IoT as a service, or IOTAs, as I like to say. Our core focus is on the application layer. So this is the part that is the user interface, the visualization, the data management, interconnectivity with all of the underlying layers, regardless of whether that's LoRaWAN or cellular or Bluetooth or Sigfox or what have you. We bring a lot of deep IoT experience. I think this is one of the things, I'm going to talk about this as we go here. There is a significant advantage to understanding the connectivity, to understanding devices, to understanding firmware when you're talking about developing an application. I think there's a lot of developers that may have had a lot of experience working on web applications, working on phone applications, desktop applications, or whatnot, and they've never really taken the time or had the exposure to the whole chain, all the way from a low-power device that needs to last for 10 years on a battery, connected over an occasionally on low-bandwidth connection. It's a very different environment than a lot of people are used to. I think it's very important to have that understanding, even if you're not directly working on all those layers. We started off originally providing primarily what I would call a self-service option, providing support to developers that would use our software to accelerate the development deployment of their IoT applications. And what we found out fairly early in the process is that most companies that are looking at or considering working on an IoT application do not have either the skill set or if they do have the skill set, they don't have the resources internally to do this. And so more and more of our customers were saying, hey, it's great that we can use your software and use your environment to develop these applications, but couldn't you just do it for us? And so we started doing more and more of that. And we do have customers that are using our software to build their own applications, but the vast majority of our customers today, we're also providing the professional services to build those applications. And that's some done internally, it's some done through partners that have software development expertise and domain expertise in certain verticals. But the bottom line is that we find that providing that turnkey comprehensive solution is what most of our customers are looking for today. And our software can run in the cloud, in the edge, is it on the edge or in the edge? I guess it depends on who you ask. And also on-premise. Frankly, we hope that people don't choose the on-premise option because it's not really good for anybody, but we do have a few customers that because of their particular environment, either from a standpoint of security or just not trusting cloud services or whatever the case may be, we do have some what I call bare metal deployments where we're running on customers' hardware inside their data centers. All right, so today what I'm going to do is talk about so IoT projects and what the risk factors are. Everything I'm going to show you today, I'm going to go through, I think there's 6 case studies in here. These are all real companies and real projects. There are no company names in this because some of them could be embarrassing. And some of them, a few of the details have been changed, but these are all real. Some of these are companies that I have either invested in or mentored. Some of these are customers of ObjectSpectrum. And basically, you know, the idea here is to look at a little snapshot of each of these particular IoT projects, the development approaches that were taken, take a look at why what I call the IoT ecosystem is so important. I really feel very strongly that having a good set of vendors, a good set of partners in a project is extremely important to the success of a project. And in fact, the examples that I have, the ones that are successful generally do have that good relationship. They have the right players at the table and the right people in the room. And then we'll talk about, you know, options and ways to reduce risk in your IoT projects. All right, so depending on who you ask or what statistics you look for, I think one of these came from a Cisco study, and there's been a number of other studies about IoT projects that are failing. Because guess what? IoT did not live up to the hype. Who would have thunk it? Okay. Well, but even though it didn't live up to the hype, there is a significant percentage of failures. I mean, 67 to 74% is a pretty big number when you talk about failed projects in the IoT space. So why? Why is this? Well, a lot of reasons. Okay. One of the things that I've seen over and over again. In fact, Ed and I just had a meeting with somebody that described this very problem yesterday. Won't say who that is, but where project requirements are not well defined up front. Okay, and not naturally, this is not unique to IoT, but it sure is something that happens a lot. Where the requirement is bullet point ability to add a user. Now what? So things like that are driven very much in the IoT space because the customer, again, back to this thing about them not having the skill set, they don't necessarily know how to even explain from a technical standpoint what they need their software to do, what they need their device to do. They may have deep domain expertise within their vertical. They may know oil and gas, they may know agriculture, they may know a piece of it, but then they're way out of their league when they start talking to other vendors and other suppliers and really trying to express what they need. So project requirements, big deal. Another thing, a little bit related to this, but also very different, is unrealistic goals or expectations. I've seen this happen many times where people start off with a project, again, not unique to IoT, but certainly something that I've seen happen over and over again, where version 1.0 is oil ocean. And it's generally not the right way to go because you end up with too many features and too many things, and people spend way too much time and money developing a feature set, and then they find out, if they're lucky enough to actually get the product to market, they find out that 12 of their 17 features the customer couldn't care less about. Okay? here's my favorite, and I'm going to give you an example that you probably all heard of in a minute here, but failure to solve any real problem. So my acronym there is IoT for the sake of IoT, because it's cool, right? So we don't know why we're doing IoT, but everybody's doing it, so we need to do that. And then they find out, of course, that because IoT is so cool, and they weren't really solving a problem that anybody cared about, they now have spent a lot of time and money developing something that they have no market for. I touched on this earlier, inexperienced development team. I don't mean that as a slam. I simply mean it as that the development teams that often are charged with this, it's a new world for them. They're getting into areas of technology that they don't have any exposure to. They tend, and I'll say later, that they tend to underestimate the complexity. It's just an antenna. How hard could it be? Okay, yeah. So the engineers in the room immediately understand what that means, right? So I think this is what happens. There's a lot, and I've seen this so many times, talking to very smart people, very well educated people, and they're like, oh yeah, we're just going to do that. And I'm like, do you realize how hard that is? And they don't. They think that, well, it's just software, right? Or it's just an antenna, or how hard could it be to build a custom sensor? Roman, how hard could it be? Yeah, okay. So, and then, obviously, one of the things that ultimately kills these projects, causes them to fail, which is, part of the net result of this is, your standard cost and schedule overruns. And I've seen lots of that where companies literally, because of a lot of these factors, they simply run out of time or run out of money. Everybody know what that is?
Yeah. Cost about $400.
700, right? Yes. If you don't know what this is, go look it up later, okay? It's a fascinating case study, okay? This was a crash and burn IoT project that pretty much has every single one of the things that you're not supposed to do involved with it, okay? So this company, they are no longer around, for those of you who know. They made a juicer, $700 internet-connected juicer. Why does it need to be internet-connected? Because it's cool. I believe it was a reporter for the Wall Street Journal says, well, you could just take this pouch and squeeze it into the glass. That was the beginning of the very quick end to that company, okay? So anyway, the point is, there's a lot of really bad IoT solutions in search of a problem out there. Don't be that. Okay, so a couple of the things that I mentioned, underestimating the complexity, not having the skill set. This is not, there's not going to be a test on these later, so you don't have to read every one of these, but this is kind of like a long list of things that are in the IoT knowledge domain. All these slides will be available, Jim, don't worry. So basically, when you look at a project that's called an IoT project, okay, there are so many different disciplines, so many different areas of expertise. I've seen way too many companies try to go it on their own, and the result is almost invariably failure. Okay, so at a very, very high level, different development approaches, the total in-house development. Don't really see a whole lot of this because, again, most companies, they realize pretty quickly that they don't have the resources, or maybe they identify at least one or two skill sets that they don't feel that they have in-house. So the other option, of course, is total outsource. I see this quite a lot. It's often a bad idea. I would say it's usually a bad idea because what ends up happening is the company says, well, I understand oil and gas, I need a sensor that does this and an application that does this. They go out and find a company and they say, here, go do this for me. And 3 years later, they're still trying to get that done. And then, of course, the hybrid, in-house, outsource, not outhouse, that's a whole different project, yeah. But the in-house outsource model, which again, I think is very important because invariably the value of the domain expertise in the industry when you're looking at an IT project is a significant piece of that puzzle, okay? We work with companies in a lot of different industries, industrial and agriculture and geo-tracking and whatnot, lots of different applications. We are not experts at all of these things. We don't know everything there is to know about machine analytics. We don't know everything there is to know about oil and gas. But the companies that we're working with, they have that domain expertise. We understand software, and we understand cloud services, and we understand the application layer and how all of this needs to fit together. And so it's very important to be able to sit down with the experts, within the customer, within the company who is basically buying the project, paying for the project, and having their expertise at the table to try to understand what the business use cases are, what the logistics are, et cetera. So that has been the best scenario, is when you've got people on the inside as well as the right ecosystem partners working on the project. I want to talk very quickly about commercial versus open source from a software standpoint and also a hardware standpoint. My focus is a little more on software right now, but this comes up a lot. I've heard from a lot of people, it's like, oh, yeah, we're going to build whatever application, we're going to build this project, and it's not going to cost anything because we're just going to use open source, okay? And that's nice. I love open source. I think it's great. There's a lot of really good open source out there, okay? And when you look at a commercial application, commercial software versus open source is not free, okay? Open source doesn't have hard costs. You're not licensing it, so that's where people get this misleading concept. But it does have soft costs. You have to spend a lot of time with it from a standpoint of vetting it, looking at security issues. You have a risk of it being abandoned or being forked, and the version you're using no longer is supported. So you have a different set of issues. I'm not going to read all this to you, but I just want to make the point, because I've heard this so many times, that, well, we're going to do open source and it's free, and so that's going to be our easy solution here. And again, when looking at any option for developing, whether it's a piece of software you're going to use in-house or a product that you're developing, it's very, very important that you understand what you're getting into. And, quote, just using open source is not necessarily the panacea that a lot of people believe it. If you do use open source, and I call this the Red Hat model because they kind of invented this idea, okay, look for options where you can use open source software, which again does have a lot of advantages, but use open source software that has an organization behind it that is supporting it, that's making sure it's got the right security patches and keeping up to date and giving you some type of life cycle guarantee, okay? It's kind of the best of both worlds if you can find it. It doesn't always exist, but it is an important aspect. Okay, so that's my open source segment of the presentation. All right, so we're going to go through and look at some case studies. I'm not going to read these to you, but we'll take a look at each one here. Again, these are just snapshots. There's no company names on any of these. They are all real. A few details have been changed to protect the guilty or the innocent. All right, so this first one, this was a company that was basically creating a shipment tracking system for commodities, okay? So think bulk goods, corn and wheat, and I'm sure lots of other things too, but... huh? What? Sow bellies? Maybe. I don't know. I mean, I think this was specifically stuff that's in a container, that can be dumped out of the container. So the part that I know about was mostly about grains and that type of thing. And so they wanted to create a specialized container for tracking this, for making sure there was, specific humidity and temperature requirements and moisture requirements and things like that. Okay, so they did this as a total outsource, okay? They had absolutely no in-house technical team whatsoever. They were a logistics broker. So they didn't own containers, they didn't own ships, they didn't own grain. They basically were coordinating all of this, and they said, hey, we got a problem. We want to understand what's going on inside these containers as they're being shipped around the world. How hard could this be, okay? And so they went to an outsourced company. They did a custom build on their sensor device. which I'll touch on that later. There are absolutely cases where that is necessary. In this case, it probably wasn't, but that's the path that they went down. And they contracted what I call a web developer, basically, and I believe this was like a one-man operation, which is fine. It's just that he didn't have any expertise at managing the firmware on the device and the connectivity. This happened to be cellular connectivity. And so they are 5 years into this project. I don't know how much money they've spent, but they've been working on it for 5 years, so you can kind of do the math on that. They're still in pilot phase, and they have severe scalability concerns right now, because with, I think the last thing I heard about this is with their pilot of 100 containers, it takes between 2 and 3 minutes to do a query and get the current status of that container. Okay, so I would say that's a scalability concern. Okay? And of course, I mean, this particular case, unfortunately, they've made a lot of bad choices in the early stages. They're living with those choices now. They happen to have the money to continue to fund this. Does everybody know what the sunk cost fallacy is? So they are deeply involved in the sunk cost fallacy right now. What they need to do is stop and start over again. But they just cannot tear themselves away from the work that they've already done. Okay, so we'll see. We'll see if this ever actually comes to market. What they have going for them is that they themselves have this need. The need itself hasn't gone away, so they continue to spend money to try to solve it. It's kind of like watching a train wreck in slow motion. All right, case study number 2. So this was a company a couple of years ago. I want to say they're based out of, I think Irving. Yeah. Okay. So they originally went out and they were going to do a fairly elaborate system having to do with preventative maintenance in machine shops. Okay, so think about lathes and drill presses and CNC machines and things like that. And what they found early on, which is good, they were actually going out and doing some market research and talking to some real customers. And you say, well, doesn't everybody do that? And the answer is no, not really. So they found out that the customers weren't really all that concerned with predictive maintenance and all this elaborate stuff they came up with. They were just like, can you tell us if the machine is running or not? That's really all they wanted at the time. So the company said, great, we can do that. We can tell you if the machine is running. They started out with a sensor device. I call it a maker build. Okay, this was based on an Arduino. Which, by the way, is a great prototyping platform. There's lots of different flavors of Arduinos and BeagleBones and Raspberry Pis and that kind of thing, and they all make great prototyping platforms. None of them are a production device, okay? But they didn't know that, so they went to market with their Arduino-based sensor. They used what I call a prototyping platform. I think the platform they used was one called Ubidots. I don't know if anybody's ever heard of that one. Again, it's a great little prototyping platform. Very quickly, you can drag and drop some stuff and have some dashboards built and have a little bit of database storage for your data, but it's not something that you can really build an application on. After about 2 years, they ran out of money and stopped. So, unfortunately, the mistake that they made is they underestimated the complexity of what they were trying to do. Even something as simple as putting sensors on machine shop equipment to tell them what the duty cycle was, whether the machine was on or off, okay? They said, sure, we can build this, we got an Arduino, we can do this, we have this this platform that we can build a prototype on, and they were never able to go from there to an actual product that they could deliver to their customer base. Even though they had customers, they had people saying, yes, come and install this, we want it, okay? But they could never make that transition. So again, I've seen that happen more than once as well. Talking about people who don't do market research, okay? So this was a company based out of Seattle, and they were going to do cold chain monitoring for fresh fish, okay? Catch to restaurant, how about that? And this was specifically for high-grade sashimi, tuna types of things. They did a hybrid design. They had in-house expertise. They're in the fish business, okay, so they know fish. They had project management internally. They had somebody who had, I think he had the ability to do this from a project management standpoint. They started at the application level, trying to figure out, because this was really about, the chain as the fish goes from the, and this is not my expertise, fish, but from the boat to the broker to, to the transport company and that type of thing. From the time you're ordering that sushi at the sushi bar, that fish has probably changed hands like 12 times from the time it was caught. So there's a lot of logistics involved there. So they thought they had a really great solution here. They were actually considering using blockchain for this. They decided not to because, again, and I applaud them for it because it was not critical to their MVP, to their minimum viable product. So again, it was a complexity that would have added a lot more development time and a lot more cost to their project, and they decided it wasn't worth it for version 1. Okay, so you think, man, these guys, they're doing everything right. They partnered with the right ecosystem vendors. This was a cellular-based device. They had one of the major carriers, an MVNO on board. They had everything going for them. They're using a COTS sensor. Does everybody know that acronym, commercial off the shelf? Okay, so using a COTS sensor, they didn't have to build something new. They found something that had been used in the pharmaceutical industry as far as a cold chain tracker, GPS and temperature, shock and that type of thing. They had everything going with them. Nobody wanted the product. They never went and talked to a single customer to see if anybody cared about this. The application was great, sensor's great, it all works great, nobody cares. So they basically shut it down. For a couple of bucks, if anybody wants a cold fish monitoring system, let me know. So again, it's just very, very important, and I wouldn't say this was IoT for the sake of IoT. This was something where the people that were doing this felt like they had a solution that was so obviously better than what was going on right now that everybody would buy it. It's the old mousetrap syndrome, of course, and they found out that nobody cared. All right, next case study. Do you know that people steal air conditioning units? Yes?
I meant to do the agricultural one, but we skipped number 4. That might have been on purpose for time.
No.
Just as a...
I'm sorry, okay. I must have hit the key bounce. Very good, okay, all right. So remote tank monitoring for agriculture, okay? So this is feed tanks in rural areas that has no network, okay? So this is basically, how do you monitor the feed that's in these tanks in such a way that you have real-time information so you can replenish them when they need to be replenished in advance. But there's no network. It's a rural area. There was no cellular coverage, no Sigfox coverage, no LoRaWAN coverage, etc. Okay. They outsourced the development of this. They had in-house subject matter experts that understood the farming aspect of it, the livestock management and that type of thing. They were not technical people at all, but they recognized this and they went and found some outsource providers that could help them. They did a number of and I really do recommend this, they did a number of quick iterations on sensors and connectivity. They were able to find sensors. Again, this was also commercial off-the-shelf sensors they were able to use. They did not have to build a custom sensor. They tried a couple of different kinds of connectivity. They ultimately ended up going with a LoRaWAN system where they were installing their own base stations. And they partnered early with key ecosystem vendors. This is including the base station vendors, the device manufacturers, and that type of thing. And they were doing successful field trials in under a year. This was actually not a very complicated project, but it was one that they were able to pull all the pieces together very quickly and get something out that worked. And this was actually deployed, right? I think it was actually just now deployed, which just within the last month or so. Okay, so this was a pretty good success story from that standpoint. They had preferred, I think, not to have to deploy their own network, but they really didn't have a choice in the matter. They were looking at, I think they ended up putting in 2 or 3 LoRa base stations per ranch. Of course, depending on the size of the ranch and that type of thing. And then these were connected with point-to-point Wi-Fi. Okay, so that was their connectivity. And they worked with, I think in their pilot, they ended up working with what's called a WISP, a wireless ISP. That was basically, taking care of climbing poles and installing things and lining up antennas and things like that. And so, that ultimately became their go-to-market strategy, is working with WISPs. There's a lot of that in rural areas, if you don't know, but where you can't just call up AT&T and have them run fiber to your house. So there's a lot of this point-to-point wireless going on in rural areas, and that was the solution that they came up with. And it works, and it wasn't super cutting edge, but it solved the problem, and they were able to do it very quickly and not very expensive. Okay, now compressor coil theft. Okay, people actually steal air conditioning systems, the compressors, while they're running. They just drive up and just yank them out and put them on the back of the truck, because the copper in the coils is worth some money. Okay, so this is a real problem. This is probably not something that anybody in this room has ever thought about. But if you look at a lot of commercial installations, they'll have little metal grates and metal fences around the compressor, and that's there to keep people from stealing the compressor. So this company was basically looking at a way to detect this, a way to alert it, and hopefully a way to catch the thieves. And they did this with a hybrid approach. They had in-house technical capability. They in fact are an HVAC company, so they understood the problems with this. They were looking to fold this in to part of their preventative maintenance contract, where they were basically looking at having that remote monitoring capability, so that they would have immediate alerting if somebody were to literally yank the compressor off the pad. They did this with a Cox sensor as well. They did their pilot. I'm trying to remember, I think they have gone to market with the Cox sensor, but they are planning to develop a custom sensor, basically as a cost reduction mechanism. So the Cox sensor it works, it solves the problem, but I think they're maybe a couple $100 a piece, and they're looking to get the sensor cost down under $100. So this is a financial decision, not really a technical one. But they are deploying these in their early deployments using the Cox sensor. They also did partner from the start with the key IoT ecosystem vendors. This particular sensor is cellular based. It's not NB-IoT or Cat M1. It's nothing exotic. It's a plain old, I think it's actually a 3G sensor. But again, it works. It was available, and it let them get to successful field trials in under 18 months. Okay, and again, that's another big factor that I've seen. The faster you can do something, the more quickly you can iterate, the more quickly you can get something into actual customer hands and start getting real feedback, the better off you are. And so they can't always do that, but in this case they did, and they would consider this to be a very successful launch. All right, my last one here. So this is a company who does predictive failure analysis on very large pumps. Okay, so think about wastewater management and freshwater management and pumps in factories and things like that. These pumps are typically running 24 hours a day. When they go down, it's very expensive downtime. And today, right now, again, this is part of what's so fun about being in this ecosystem is, getting a little view into all these different vertical applications, okay? And you wonder, it's like, well, how do people monitor these pumps today, okay? The answer is about once every 6 months, a guy goes around with a little handheld meter and touches it to the pump, gets the vibration and goes, yeah, that's good, and goes on to the next pump, okay? As you can imagine, that's not necessarily the best way to go about doing this, okay? So this particular company, also a hybrid approach, their in-house expertise is electrical engineering and firmware development, and they have a very unique RF-powered sensor. There's no batteries in it. It actually receives its power from what they call a transponder, which is communicating to the device using Bluetooth, using BLE. And then it also sends power to the device that gives it its ability. The reason that this was so important is because, and again, this is where you find these little subtleties. If you have to physically install a sensor on one of these pumps, and it needs to have a wire, it has to be inside conduit. This is building code, okay? If it's inside conduit, the cost to install a sensor on one of these machines can be $2,000 to $3,000, okay? And you say, well, that's just dumb. Why don't you put a battery in it? Great, okay? So you can do that too, except that some of this company's customers, they might have 400 or 500 of these pumps spread out over factories all over the world, okay? And so they start deploying these sensors. Each pump will have anywhere from 4 to 10 sensors located in different positions on the pump, measuring different parts of its rotation. They can actually get to the point where they can say, ball bearing number 12 on the rear pressure bearing is going to fail within 6 months. How about that? Okay, it's really very interesting. But the battery-powered solution is just not a workable solution for them, because even if the battery could last 5 years, and I think in their case, based on what they needed the device to do, they were looking at a 2 to 3 year battery life. That level of maintenance to go out and replace those sensors every 2 to 3 years, which was in fact the sort of state of the art. If you get behind, if you go past the guy with a little device every 6 months, okay, battery-powered sensors was the other option, but people really were not adopting that because they didn't want the overhead of having to go and replace the batteries every 2 to 3 years. So the RF-powered sensor was a big deal here. That was their core competency. They initially outsourced their application, again, to a web developer. They recognized very early that that was not going to work. They were doing that really as kind of a proof of concept. It was fine for that. They ultimately ended up, well, this is an ObjectSpectrum customer, they ended up going to ObjectSpectrum to develop their application. They spent 4 years developing this because most of their effort was in the development of that sensor, the RF power distribution and that type of thing. And then they started their first deployments third quarter of last year. So I think they have about 14 customers now, and these are all fairly large companies, municipalities, because small companies don't have hundreds of giant pumps. So, all right, so those are my case studies. So some key takeaways from this is start with an MVP that solves a real problem. Okay, and again, that's not unique to IoT, but I think the hype around IoT maybe makes it a little bit more common here in this space. Clearly define the project and the product goals. Again, I've seen this happen too, where you end up with a lot of feature creep, because you've got a lot of people talking about, well, gee, if we can do this, why don't we add that feature? And gosh, wouldn't it be great if we could do that? And hey, add blockchain, because that's cool, and so you get a lot of that kind of stuff going on.
Eric,
yeah.
MVP is a
minimum viable product.
Minimum. Okay.
Yeah. And that's not my term. That's a fairly used term in the software business, but I think it applies to hardware product as well. The idea is your version 1, whatever you're going to first come out with, you need to be really, really disciplined at not putting so many features in it that you end up creating something that you're taking longer to get to market, you're taking longer to get customer feedback, and then you find out that these things that you spent hundreds of man hours on that nobody cares about. So you're trying to reduce your risk by being very, very disciplined about what that feature set looks like. What do you need to have a functional product? What solves the requirement? Incremental steps and iterate quickly. This is again another thing, and again, depending upon the application and whether you're having to build custom hardware, I understand that sometimes this is difficult to do, but again, the idea is if you can say, all right, we know what version 1 needs to look like, we know what version 1.1, 1.2, and so on. Don't make these 1 year and 2 year development cycles. Make these 1 month and 2 month development cycles, because you're going to learn so much once you have real use cases. You're going to find things that you can never figure out just by doing it in your own lab, just by doing it with a pilot, 1 or 2 pilot customers. So it's very important to look at the project in a way that you can iterate quickly. Definitely don't expect version 1 to be the final solution. This gets back to the boil the ocean problem. People look at it and they go, yeah, but if we're going to do X, Y, and Z, why don't we do PD and Q too? Because obviously people will want that. And the answer is, of course they will. Let them come back and buy that as your second version, okay? Because again, you're back to this thing of we're creating a project that's so complex and has so many moving parts that you're almost setting yourself up for a higher risk of failure. I mentioned this a couple of times, and I have another slide. I'm going to drill down on this a little bit. Use Cox Hardware wherever you can, okay? That will not always be the case. I'll talk about that in a second. But if you are in a position where you can at least do your early proof of concept, your early pilots, using some hardware that you can go and buy off the shelf, even if it's too expensive, even if it's not exactly the packaging that you need and that kind of thing, if you can make it work, you will be much better off if you go that route, okay? And very importantly, leverage the IoT ecosystem at every layer. Understand what vendors you need, understand what functional elements you need to make this successful. Is this going to be a cellular-based system? Who's making your radio modules? What devices are you using? What carriers are you using? Are you going to go directly to an AT&T or a Verizon? Or are you going to go to an MVNO? Okay? These are all very complex questions, and the answer is always, it depends. Okay? What type of software are you going to use? What type of application? Who are the personas of your end users? Is there just one type of them, or are there multiple personas? Maybe there's a manager type and a user type. So these are all very important things to figure out. And once you understand all those, then you can figure out who needs to be at the table. All right. I want to just talk a bit about Cox Hardware. The sad fact is that the hardware that you need probably doesn't exist. It's good for you, Roman. So, from an order of kind of the easiest, least capital intensive, lowest risk to the inverse of that, the hardest and the highest risk, Cox is the easiest. And I didn't say the cheapest, because it may not be the cheapest, okay, but it's the lowest risk, because you can go, you can pick one up and you can see it and you can play with it right now, okay? When you get all the way up to full custom, okay, you are months, if not a year away from having a device that you can play with, okay? They call it hardware for a reason, because it's hard, really hard, okay? So the thing that I've seen in most cases is they fall in one of 3 categories. The smallest of those categories is a product or project that can basically go to full production with Cox hardware, okay? It does exist, okay? If you're doing something that involves vehicle tracking, I think there's at least 20 vendors out there that will sell you a vehicle tracker that's probably going to meet your needs. You probably don't need to design that, okay? If you think you want to make a GPS dog collar, don't. But if you think you want to do that, there's at least 20 companies that already have a GPS dog collar. You can probably go find that, okay? So that's kind of one category. The other category, which is the COTS product is not going to work for us in production, but we can at least proof of concept with it. We can maybe do early deployments with it, okay? Even though it might be too big, too expensive, or not have one or two of the features that you need. Or, I mean, I have literally seen companies take two COTS product and duct tape them together because that's what the product needs to do, okay? And it's fine. You're not going to go to production like that, okay? But it's a way to test your concept. It's a way to get customer feedback. And then, of course, you work yourself up the levels. There's different flavors of modular where you can do literally things that snap together where you've got one of these and two of these, okay? Those tend to be expensive, but they're faster to get to market. You've got PCB modular, where you're basically doing system on a chip or system on a module type stuff, and then all the way up to full custom, custom circuit board layout and everything else. And the fact is, that is the third category, is your product simply will not work without a fully custom device, okay?
But would you say that the initial deployment, you don't necessarily go minimum viable product for the hardware because you want to have the exploratory options?
It depends.
And then you evolve to the minimum that actually works?
Sometimes, yeah. I mean, unfortunately, there is almost no generic way to express that. You almost have to say, all right, this is what you're trying to do. Okay, what are your requirements? What's available that can solve this particular problem? What can you use to get meaningful data back, even if it has, like I said, too much cost or too big of a size or what have you. And you're right, you may be in cases where it's like, well, we needed this particular sensor. It gives us 3 other pieces of information. Great, okay? But maybe we learned something from that too. So absolutely. And typically, here's the other factor too. I was working with a company about 2 years ago, and they were building a custom device. Okay, it wasn't what I call a full custom. They weren't. It wasn't actually a circuit board, but they were manufacturing something that was made from like 3 or 4 different vendors' modules and putting it in an enclosure. And they were doing this because they said, well, this is the way that we can get the cost down. All right, great. Okay, how many of these are you planning to deploy? About 100. Probably a lot of wasted time to get the cost down on deploying 100 units, okay, to go through the level of trouble that they did. So again, you got to take all these factors into account.
I guess there's maybe one more category,
okay.
Which is like a COTS with semi-custom customization. So
I'm kind of including that like assembly modular. I didn't have a way to express that, but that's what I mean by that. So it's cost, but you can say, I have this baseboard and these modules, like your stuff.
Actually, having something that is deployable with the enclosure and all
Absolutely.
that, but maybe with some software customizations, you can
Absolutely.
do different sensors.
100%, yeah. And that's the thing. That's, again, hard to look at generically. This isn't meant to be an absolute list. These are only 5 categories. There are no more. It's kind of a continuum from, can I go to Best Buy and buy it? Not really Best Buy, but can I go order it offline, or do I have to build it from scratch? And in between, there's a lot of different layers, okay? And my point about this is that people have to be very thoughtful about where they want to be on this continuum. And I've seen more than one company spend a lot of time developing a device. There's a company here in Dallas, which I won't name them. They've been at it for about 3 years, working, it's not one of the case studies, working on their device, okay? As far as I can tell, their device was just fine about 2 years ago, but they keep working on the device, okay? And because they're enamored with it, and they want to keep refining it and keep making it better. It's like, at some point, why don't you go sell some of those, because that's what you eventually need to do.
So for IoT, the key factor is how fast can you get the deployment?
Absolutely, yes, very, very much so, okay, because again, why is that important? Well, first of all, you're going to learn something if you do that. Second of all, you may run out of money before you get something into the marketplace, okay? And third of all, there's probably competition out there too, that they're working every day to get there before you are. So. Okay, and the last thing too, I want to say, kind of a note about the ecosystem. I say you want to know your partners and you want to know that you can trust your partners, okay? There's a lot of different people that are in that ecosystem, application software development, device and edge firmware development. I'm not going to read all that to you, but basically when you look at who needs to be at the table for your particular product, okay, understand who's in the room, okay? The fact is, if you go to somebody who is selling a particular product, okay, they're going to be very interested in making that product part of your product, okay? Well, be aware of that, okay? The reason that there are so many different kinds of wireless technologies, the reason that there are so many different types of embedded systems is because there isn't one solution that will cover all problems, okay? So the point is, you have to be smart about understanding what your options are, explore the options, figure out who needs to be at the table, and then know who your partners are. Q&A? Todd?
Back in 1993, I was volunteered to participate in an IDF2 entity modeling functional process improvements.
Okay.
Is that still a thing?
It certainly is. I mean, you typically, a lot of the focus that I'm talking about here has to do with how do you get to the point where you have a product in the market that you can get real customer feedback from. Because so much of what's going on in IoT it is new. It's different than what people are doing now. I think what you're talking about is, in many cases, going to be part of that design process. Some cases not. It depends upon the thing. But like, when you're talking about building a device, one of the places that I see that kind of technology being used for is like characterizing the thermal conductivity of the enclosure and stuff like that. Okay, is that the kind of thing you're talking about?
Well, the way it was explained to me,
Yeah.
again, 20 years,
Yeah.
was that after you completed your entity modeling and you completed your study, then the results of the study could be handed to, and it was explained to me, as software engineers,
Right.
who could then design a system that would have this functionality embedded in it.
Yeah, I mean, I think to varying degrees, that's part of the detailed design process, and so when you say, well, I didn't drill down into what does it take to design a piece of software, what does it design to take a piece of hardware, I think that kind of stuff does come in at that level. This is kind of at 10,000 feet right here.
No, I understand.
But yeah, no,
I was
think-
just curious to see if everybody's still doing it.
I think that exists in a number of different ways. Everything from doing those studies with wireframes and focus groups and all the stuff where you collect that data and make use of that, so you have a well thought out set of requirements that you can now determine what your MVP needs to look like from that. So
I was going to
Yes.
comment, there's a lot of books out there about MVP, Lean Startup.
Lean Startup,
The Bible,
absolutely.
Eric Ries.
Yep.
And wouldn't you agree that sometimes the MVP isn't even a product, it's actually, like in the case of the fish temperature, it could have just been a video.
Absolutely.
That goes to these people and say, is this what you want?
100%.
And that's what
100%.
Eric talked about.
Absolutely, yeah. Well, in fact, we recently did, and we do this all the time at ObjectSpectrum, but we did a demo prototype, okay? So that our customer could show what they were going to do. It didn't work, okay, but it looked like it worked.
Right.
but it's something I think it took 4 hours to build, okay? But it let them walk in and pull it up on the screen and say, see, here's how your data is going to be displayed, and this is how you do this, and watch, when we set off this alarm over here, you see how this comes up? And so it was just functional enough that they could take it out and show it to their prospective customers, and they learned so much from that it actually changed some of their requirements, okay?
Yeah.
So that absolutely falls into this concept of this iterate quickly. You want to get that feedback as soon as you can. And it's a big difference. You say a video, absolutely, sometimes that can be the thing. It's a way, what is the way basically for the thing you're trying to describe? How do you put that in front of somebody in a way that they can understand it? Okay, and that might be a demo, it might be a video, But yes, 100%, that's exactly what I think works very well. Yes?
So let's say you're a low-tech company, and you want to automate some of your processes.
Yeah.
You have no clue about technology.
Right.
How do you start?
You know, my personal experience has been that most of the time, they don't start.
Well, wouldn't the actual answer be that you call ObjectSpectrum?
What's that?
Wouldn't the actual answer be you call ObjectSpectrum? I mean,
Sure.
Well, in most cases, they don't start until they see their competitors
That's
do
right.
something.
That's exactly
When they see
right.
their competitor do
Yeah.
it, they say, who's doing it for them, and then I'm gonna jump on the bandwagon.
Yeah, yeah. I mean, it's a really difficult problem, okay? Because you're right, okay, and this is absolutely true. I've talked to lots and lots of companies that really should have an IoT initiative, because if they don't, somebody's gonna eat their lunch, okay? But they don't know it yet, okay? They're like, we've been in this business for 100 years. Why would we want to change, okay? So, you know, those are hard ones, okay? And of course, they, like we say, they don't have any expertise here. They don't even know who to call, okay? So maybe they go to an IoT trade show and they talk to some people or whatever. But I mean, ultimately, you know, it can be a very dangerous situation, you know. It'd be like you walking into an industry that you knew absolutely nothing about, and now you're trying to figure out who you should talk to and who the right people are that can help you get your problem solved. It's very tricky. Absolutely. Yes.
So in terms of, I guess going back to startups and the case studies that we saw,
Yeah.
in terms of volume of solutions
Yes.
per region, or how many consumers you're getting as
Yeah.
a result of your project or your
Yeah.
IoT, you know, case studies, type stuff, where do you see the most, I guess, success in terms of solutions? Is it more of like this is a single product, or hey, we have certain data visualizations or data analytics that we can get for you? Where do you see in the IoT world, where is more, what I'm trying to say,
Yeah.
where's the need more? Where are there more consumers? Where are there more need?
I think there's many layers to that question, okay? And so, you know, if you are in the business of doing machine learning models, which is a very specialized expertise, there are absolutely customers out there for you. But they're not the same customers that are buying a finished product that solves a problem for this kind of agriculture requirement that happens to use machine learning inside of it. So this is back to this whole ecosystem, you know?
Do you see there's any part of the market where you're reaching like just day-to-day consumers, not specialized companies?
So we do not, okay? And again, this is part of the tyranny of the term IoT, right? Is that it means all things, right? And so it's from a wearable to a satellite and everything in between. And so our particular customer base and where we focus are IoT applications that need cloud services, okay? And so if you're doing a fitness tracker, just as an example, where it connects to your Bluetooth phone, that's probably not our customer, okay? You know, your volume, you know, as far as number of customers, I mean, it's very big in the consumer space. There are lots of IoT applications in the consumer space. What we have seen, because we're mostly in the industrial, agriculture, commercial spaces, a lot of stuff going on with agriculture right now. You would think that was a sleepy old industry that you know, that nobody cares about. Okay, it is very interested in high tech and is very interested in IoT. Lots of different factors are driving that. So you have people, you know, they've been in the farming business, you know, for generations. That are now deploying their own LoRaWAN networks in order to maintain real-time information about how they're irrigating their 100,000 acres of wheat and things like that. So there's a lot going on there. There's a lot going on in the industrial space too. It has its own term, IIoT, right? Industrial IoT. A lot going on there. Much of it having to do with predictive analytics and predictive maintenance, where the idea is to figure out if this machine is going to fail before you have a downtime that was unplanned, because that's a huge revenue and or cost driver associated with that. Paul?
the things we've had some success with some of the companies I work with, is figuring out what the volume components are gonna be based on other drivers, not us, knowing that we're gonna be a small player. For example, I look at sensors and, you know, this phone's got a temperature thermistor, a magnetometer, a MEMS device, an optic device, a GPS, and a barometer. I might not need all those things, but whichever one I pick, it's kind of important to understand, did I pick the one that's used on the iPhone 5?
Right.
And is that gonna be like an unobtainium next month?
Could be,
Or do I figure out that it's the Pixel 2 one that's probably gonna have the long legs? And then couple that with some of the semiconductor makers are getting wiser now, doing that integration slide you showed, where you can now do that at the chip level. So you can say, on this radio, this power device,
Absolutely.
but leave off the GPS, but bring me in BLE,
Right.
and then make your chips like that really don't cost about the same as if you bought the chip separately.
Absolutely.
And, you know, good example, Silicon Labs, Dialog Semiconductor, Texas Instruments.
Sure.
How do you feel about using that? In other words,
100%.
wiring in real tight with who the big dogs are and running with them, and also who makes the food for the big dogs, and figure out what their food plan looks like.
Absolutely. Well, and in fact, I mean, what you're describing is why this thing that we call IoT exists. It's because of that supercomputer you're holding in your hand right there, okay? Because, you know, 10 years ago, a GPS was a thing about this big.
Yeah, it's only used for bass fishing.
Yeah, exactly, okay? And so now it's something that fits on the end of your fingernail. And so there are both pros and cons to that. The pros are is you've got access to all these great sensors that are small and cheap and generally available until Apple decides that they need all 1 million of them this month that are being produced. So you absolutely have those problems. And that gets in, again, we're at 10,000 feet, you know, in this presentation. That gets into the complexities of designing hardware, or in some cases, the complexities of choosing a supplier for an off-the-shelf piece of hardware. What parts are they using that may be a problem? And, you know, a lot of people in the room probably know one of the bizarre things in the hardware world right now is that popcorn logic and resistors and capacitors are on allocation right now, okay? And so you would never think that that would be a problem, but it is. And so, you know, when you are planning to build a piece of hardware, that's part of the equation. And you say, gee, you know, these parts that we chose to design into our board, you know, they're on allocation for 42 weeks. Now what? So yeah, that's a big.
We beat up Avnet, right?
That's exactly right. Yeah, 100%. So. All right. Well, thank you much, everybody. Thanks for coming out. Please do go onto our LinkedIn company page and follow us. And we're just, you know, since 2016, we haven't really been doing a lot of marketing. We now have Andy on board. We're going to be doing more marketing now. We're going to be looking at how we can kind of leverage the things that we've learned and the things that we encounter on a daily basis to really provide some information that's useful. We're not going to be sending out spam or anything like that. But please do follow us on LinkedIn. That'll be kind of our primary outlet for that right now. So
Just
thank
give
you
him a
very
hand,
much, guys.